Converting inches in fraction form to millimeters in decimal form. Millimeters units is required in many business. Since most of us is familiar with inches, it's helpful to know the conversion. Convert the fraction to a decimal by dividing the top of the fraction by the bottom. Divide the decimal equivalent by 25.4, and 25.4 millimeters equals 1 inch. For example, 1/2 equals 1 divided by 2, which equals 0.500. Then you take 0.500 times 25.4 equals 12.7 millimeters. Also, another example is listed below, the 1/8. Calculating the area of a circle. First, we got to understand some definitions. The radius is a straight line from the center to the edge of the circle. The diameter is a straight line passing from one side to side through the other side from the center of the circle. Pi is the number that equals to approximately 3.14.5. It is the circumference of any circle divided by its diameter. So the area of a circle is A equals pi radius squared. So let's do an example here. The diameter is 12 inch. If you want to find the radius, which is half the diameter, you go 12 divided by 2, which is equals to 6. So the radius is 6. And the area is 3.14 times 6 squared equals 3.14 times 6 times 6. So 3.14 times 36 equals 113.09 inches squared. Okay, now we're going to calculate the maximum tensile strength of a diameter area. When calculating the maximum tensile strength of a diameter bar, you need two different formulas. First, you need the area of the circle, which is pi times radius squared. And then you will need the tensile strength formula, which is load divided by area. Example, calculate maximum tensile strength of a bar with a diameter of 0.25 inches or 250 thousandths of an inch, and a failure load of 20,100 pounds. So first we're going to find the area, which is pi times radius squared. So pi is 3.1415 times radius, which is 0.25 divided by 2 times 0.25 divided by 2, which equals, next is you go 3.1415 times 0.125 times 0.125 equals 0.049 inches squared. Next, we're going to find the tensile strength, which is load over area. The load failed at 20,100 pounds divided by 0.049. The answer would be 410,201.08 pounds per square inch. Take a second and look at the notes below because it can get really confusing. Like for your information, note that the standard diameter of a tensile specimen is 1/2 inch in diameter. But note that the standard area of a tensile specimen is 0.1963 square inches. So make sure you read those questions correctly. Next one is pretty simple. The area of a rectangular is pretty simple. It's thickness times width. Here's an example. Calculate the maximum tensile strength of a rectangular specimen with a thickness of 0.337 and a width of 0.790. The failure load is 35,100 pounds. So the area is thickness times width, which is 0.337 times 0.790 equals 0.266 inch squared. Next is the tensile strength, load over area. So it's 35,100 divided by 0.266, which equals 131,954 pounds per square inch. First, you take the final center punch minus original center punch divided by the original center point times 100. Example below. Calculate the percentage of elongation in a bar with the original center punch of 2 and the final center punch of 2.250. So first you take the final center point minus the original center point. The final center point is 2.250 minus 2 equals 0.250. So then you take 0.250 divided by 2, which is equals to 0.125. Then you take 0.125 times 100, which equals 12.5%. So that's your elongation. Especially to an inspector, is finding the reduction of area in a tensile specimen. So first you take the original area minus the final area. Then you divide it by the original area times 100. Example, calculate the percentage reduction of area for a bar with the original area of 2.6 inch squared and a final area of 2.15 inch squared. So original area minus final area equals 2.6 inch squared minus 2.15 inch squared equals 0.45 inch squared. Then you take 0.45 inch squared divided by 2.6 inch squared equals 0.1731. Then you take 0.1731 times 100 equals 17.31%. Is directly related to welding. It is the heat input. So heat input equals volts times amps times 60 divided by travel speed in inches per minute or millimeters per minute. So here's an example. Calculate the heat input. You have a voltage of 30, amperage of 175, and travel speed of 9.5 inches per minute. So volts times amps times 60 equals 30, which is the voltage, times the amperage, 175, times 60 equals 315,000. Then you take 315,000 divided by 9.5 equals 33,157.89 joules per inch. It's a note below. To convert joules into kilojoules, move the decimal 3 times to the left.